Hi everyone, and welcome to our video on using a calculator to graph these piecewise functions, or a piecewise function and another function, to find the limits. All right, so with a calculator, so I just use Desmos because usually we're online doing the homework. If you have a TI 83 or 84, you can follow similar steps, but you just might need to Google TI 83, 84 graphing. This is a lot easier. So I'm at desmos.com and I'm just going to go to graphing calculator. And then from here, I'm just going to enter the function. So number one is 4x plus 3 over x minus 2. So we type it in exactly as we see it. So 4x plus 3, and then I'm going to highlight all of it, divided by x minus 2. And then I'm just going to double check 4x plus 3, x minus 2. Okay, if you're using a TI 83 or 84, you might need parentheses around these. So I'm going to put them in also. Otherwise, it might not give you the same thing because it's formatted differently. All right, and then let's see it a little bigger. There we go. Okay, and we can zoom in and zoom out. That's why Desmos is nice. Okay, so here's our graph. All right, and then with our graph, they first want us to find the limit as x goes to infinity. So remember that just means that is x going to the far right. Far right. And then this answer is what does y look like? So this is like a y value. So what does y look like to the far right? Okay, so in our calculator, I can zoom and we can kind of see it looks kind of just like a horizontal line. It looks like the decimal keeps getting smaller and smaller. It looks like it's close to 4. Okay, so let's really zoom out. Far right. Notice it's getting even closer to 4. Okay, so 4.001. Eventually it just is going to round. It looks like it's staying at 4.001. But look at that. It just rounds it to 4 eventually. So as far right as I want to go, it looks like my y value is just going to be 4. Okay, so that's going to be the answer to that question. So I'm just zooming back out to get, and you can even see it's like a horizontal line. So 4, 4, 4, 4, 4. Notice when you zoom far out, you can't really see much on the rest of the graph. So careful with zooming, because when we zoom in, we can see, oh yeah, there is curve to it. Okay, so there it is. Okay, anyway, so as far right as possible, it was 4. Okay, so that was our answer. So that's that limit. So as it goes to the right forever, it looks like the y is getting very close to 4. And then this is the limit as x goes to 2. Okay, so x getting very close to 2. What's y getting close to? All right, so x getting close to 2. I'm going to zoom in. Here's where 2 is. And then notice we have two separate branches. One looks like it goes up forever. One looks like it goes down forever. For a limit to exist, they need to be going to the same thing. Okay, so to the left, it's going down forever. To the right of it, it's going up forever. Those are going in different directions because they're going differently. One's going up to infinity, one's going down to negative infinity. That means this is a does not exist. Okay, and we could even kind of just do a quick sketch to point that out. So it's something like this. Okay, so remember this is going up to the right. So this is the limit as x goes to 2 from the right of this function is going up to infinity. This part, that's the limit as x goes to 2 from the left. And that's going down to negative infinity. Because these are different, remember, if these are different, that means that the limit does not exist. Okay, if they are the same, then that would be the final answer. It's the same thing. Okay, let's see how we can graph a piecewise function. So a piecewise function has two different pieces into it. All right, so I'm going to color code. Let's do this one in blue. And then let's do this one in red. Okay, so I'm going to erase the other one. So 2x minus 1 is one of the graphs. Okay, so I'm going to go here. I'm going to erase this. 2x minus 1. There we go. And then I'm going to change that color in a second. This one's x squared plus 2. So x squared plus 2. Nope, looks like they were the opposite of what I wanted. Okay, so let's change it just for matching what I boxed. Okay, so there they are. So they're both right here. They're both in the picture. Now we do have to pay attention, and this is what it would look like in an 83 or 84. So you would have all of both graphs. They're both here. On Desmos, you can graph the piecewise function using what they say with the x value. So we can use that in the graph. However, sometimes it might not even be worth it. So let's look at our limit. So this is -3 from the left. That's the blue graph is what we would want to focus on. Okay, so let's star that. So -3 from the left, because that's what this is saying. So this is x is less than -3. So that means it's left of -3. Okay, so that means I want to look at the blue graph and really just find where x is -3. Okay, so here's my blue graph, x -3, and it's right here. That's it. Okay, so it's -7 is the y coordinate. So that is that limit. That's it. Remember, the limit is similar to a y coordinate. On this one, it is just -7. Okay, so that's it. So this is -7. And then the limit as x goes to -3 from the right. So that's this red graph. This is x is greater than or equal to -3, but the greater than portion is the right part. So remember that little plus sign. So we're right of -3. Okay, so let's box that. And then so that means I'm looking at the red graph. Where is -3 on the red graph? Looks like on this grid it's 11. Okay, so that's our y coordinate there. All right, so that's all there is to it. So piecewise functions aren't too bad. Again, a graphing calculator will show those. Now I did cloud that, so if you do want to graph the whole piecewise function in Desmos, you just use braces and then type in what it said. So there is the less than, and then here was the x is greater than or equal to -3, like that. And so we can see there they are. So if we do want to see if we need to graph the actual piecewise function, that's a way to do it. Okay, so the whole graph, okay, notice it shows it's undefined because of the inequality symbol, but if we zoom in, we can see, oh yeah, it's still close to -7, and that would still be the answer from the left side. Okay, so this is a way to graph piecewise functions. Okay, anyway, that's it. So finding the limit, use that calculator, zoom in, zoom out. If you have a TI 83 or 84, I mean, it's done similar way. It just might take a little longer with the zooming, but that's it. All right, so thanks for watching. If you have questions, please let me know.